So let's price a call with an exercise price of $100. So that means if I own one of these, if I buy one of these calls, then I get to buy the stock for $100. Let's say we know that there's a 90% chance that the stock's going to go up to $101 and a 10% chance that it's going to be drop down to $99. So this looks like a good, there's 90% chance that the stock will go up and my call will be worth $1. I'll get to buy a $101 stock for $100 next month. Let's organize ourselves by setting up a binomial step. Right now, in the present, the stock is worth $100. There's a 90% chance it's going to go up to $101. There's a 10% chance that it's going to go down to $99. If, in the most likely scenario, the stock goes up, our call option is going to be worth $1. The less likely scenario, our call option will be worth nothing. It'll expire worthless because I wouldn't pay $100 for the stock in that future where the stock is trading in the market for $99. I want to know, though, how much should I pay for this call option now? It shouldn't be $1 because even though I expect it to be worth $1 next month, there is a chance that it's worth nothing. So it should probably be worth less. I would pay less than $1 for that. But it shouldn't be worth nothing because most likely I'm going to end up cashing it in for $1. So I expect to get some number in between its maximum of 1 and its minimum of 0. I expect the value, I expect to pay the value, something in between 0 and 1. Just looking at this 90% chance it's going to go up to 101, I expect the number to be, right now I'm thinking, closer to 1 than to 0. But let's figure it out. The whole trick here is going to be, in the present, I set up a portfolio where I buy one of these options for V. Now, I don't know how much V is. I don't know what I'm paying yet, but we'll figure that out. And I short some stock. So delta is a number. Delta is the number of stocks that I short. Why I set up a portfolio like this is because I want to hedge away risk. I want to. I don't want to take the chance that I lose money. I don't want to take the risk. So our portfolio here, if the stock goes up, excellent. Our V goes up to 1, but so our V goes up, but our debt, our negative, we shorted the stock, we owe that. Since the stock goes up, our debt gets worse. So it balances. The V goes up, but our debt gets worse. If the possible future here where the stock goes to 99, our V goes down, but our debt gets smaller. So this portfolio is going to balance the two futures. I want to balance those two futures exactly so that it doesn't matter if the stock goes up or the stock goes down, my portfolio stays the same. So let's figure this out. I'm going to call that pi plus portfolio plus if the stock goes up. That would be equal to, now the portfolio is always V minus delta S. So that'll be V in that possible future minus delta times the stock value. If the stock goes down, V minus delta S. Those are the values of my portfolio in the two possible futures. If I set these equal to each other, that's me hedging away the risk. Then I've got 1 minus delta 101 is equal to 0 minus delta 99, and I can solve for the delta then. I get a delta equals a half. So I got to pick, back here in the present, I got to pick what delta is. If I pick delta equal to a half, then it doesn't matter if the stock goes up or the stock goes down. Both future values of my portfolio is minus $49.50. So pi up equals pi down. They both equal minus $4.50 or minus $49.50. That means that my portfolio now, which is V minus, I know what delta is, it's a half, and I know the stock value is $100. So my portfolio now is V minus $50. That should be equal to my portfolio value in the future, minus $49.50. Why? A no arbitrage argument. So that means the V must be worth 50 cents. So the fair price for this call option is 50 cents. Oh, and that was I knew it was going to be a number in between 1 and 0. It's actually dead in the middle between 1 and 0. Oh, dead in the middle between 1 and 0. I was sort of thinking at the beginning it would be closer to 1 because there's like a 90% chance that the stock was going up. But I never used this 90% and 10%. There's no probability in this whole equation. In all this math process we did, there's no probability. In fact, if I were to just change this to, like, I don't know, switch them, there's like a 20% chance it goes up and there's an 80% chance it goes down. That doesn't change the value of the call option. Oh, why? Because that's the risk. The chance it goes up, the chance it goes down. That's the risk. We hedged away the risk by picking the right delta. So the probabilities don't matter. We made the probabilities not matter by picking the correct delta. So this will be true for all of our pricing of options. The probability that the stock goes up, the drift, if I'm talking about a real stock, doesn't affect the price of the option. Now, let's clear up some concerns here. The first concern would be, wow, your portfolio is worth negative $49.50 in both cases of the future. That can't be good. Well, keep in mind that over here in the present, I'm shorting half $100 stock. So I'm getting $50 cash when I short that half a stock. So when I get the $50 cash, I take 50 cents of that $50 cash and buy the call option. The rest of the money, the $49.50, I can just keep in my pocket, and then in both cases of the future, I have $49.50 in my pocket, and my portfolio is worth minus $49.50, so I can cover this negative and end up with nothing. I start with nothing and I end with nothing. Okay, well, that doesn't sound good. But it does when you think about that this is a portfolio where I have eliminated the risk. So I've used it to price the call option, but most importantly, I've eliminated the risk here. What we don't have, though, is time value of money. So let's think if we put time value of money in here. Well, we need an interest rate. Let's just, for now, say the interest rate is, the risk-free rate of interest is 1%. That means that the amount of money that I would, my portfolio would be worth now, I would multiply that by 1 plus R over 12 because my time step is a month. So R times dt. And that would be equal to what my portfolio would be worth in the future. So this amount of money grows at this amount of interest rate to be equal to this future value. Well, that's V minus 50. I'm putting in what the portfolio now is worth, is equal to 1 over 1 plus 0.01 times 12 times this future value of minus 49.50. And when I solve for the V here, I get 54 cents. But still, these probabilities didn't play any part in it. I got a slightly higher value when I counted time value of money. A slightly higher value. Okay, let's, for now, get rid of this time value of money part. We'll consider it later. But what happens if it's a different kind of option? So I'm going to change this from a call to a put. And I'm going to make the exercise price of this put $105. So now the stock can go up to $101. Oh, a put means I can make someone buy this stock for $105. If the stock goes up to $101, my put option is worth $4. I get to make someone buy a $101 item for $105. If the stock goes down to $99, I get to make someone buy a $99 item for $105, then the value of my option will be worth $6 in that case of the future. So that means if the portfolio goes up, if the stock goes up, my portfolio up is 4 minus delta 101. If the stock goes down, it's 6 minus delta 99. I do the same idea here, and really I didn't erase all this math because I'm just swapping out the 1 and the 0 for the 4 and the 6. And now I've got a delta of minus 1. So, okay, wait a minute. Can I have a delta of negative? Yeah, that delta, what does delta mean? Delta is the number of shares that I short. So negative shorting is the opposite of shorting, that's buying. So over here in the present, I'm supposed to buy a share. So my portfolio should be equal to, pi now, should be buy that put option for V, we haven't figured out what V is yet, and also buy 1 share of stock. In both cases of the future, with delta equal to minus 1, in both cases of the future, my portfolio would be worth $105. So portfolio now equals portfolio in the future. So that V must be $5. Yeah, I got a value in between its minimum value of 4 and its maximum value of 6. I got a value dead in between. And again, this I never did anything with these probabilities. They're irrelevant because I've hedged it out. So I should pay $5 for this call option. I got rid of those probabilities, but if I was pricing this with a probability, it looks like, since the $5 is dead in between the 4 and the 6, it looks like if I took probability that it's 4 plus probability that it's 6 and then 1 minus, that I would get, and I ended up that being 5, it looks like if I used a probability of a half, if there's half the time it goes up to 101 and half the time it goes down to 99, then I would get the correct price. So, but that's this if I used a half. I'm sort of back figuring that half out because I had to know the value of the call option. I had to know the value of the call option before I could figure out the probabilities of a half and a half. And they're not the real probabilities. We didn't use the real probabilities. So what is this probability? This is going to be our risk neutral probability. So if you were pricing call options with a probability, you would have to use, or put options or any options. In fact, go back and look at the probability for the call example we just did. We'll also get a half in that case. If we were pricing options with a risk neutral probability, then we could use the expected value if I use the risk neutral probability. I can't use the actual expected value. I can use the expected value using risk neutral probabilities.